Hello guys, welcome to this class. In the last class we talked about matching and we dropped some formulas, and in this class we are going to be continuing from where we stopped. So what we are going to be explaining now is type of matching. The first type of matching I would like to drop here is called the lever. Number one, lever. The levers. Number two, we have the pulley. Number three, we talked about inclined plane. After inclined plane, number four, we'll talk about wheel and axle. Number five, after wheel and axle, we'll talk about screw. Screw jack. And after screw jack, we now, I think we are okay there. Yes, from screw jack. Okay. Yeah, number five, screw jack. Okay, number six, we'll now talk about gears. Or gears, anyone you call it. Gears. So these are the 6 classes of machines that we will talk about. So first of all, let's go into it one after the other. Now note that each type of machines may have their own velocity ratio. What differs in those machines, lever, pulley, inclined plane, are their velocity ratios. Their velocity ratios have different formulas, and that's what we are going to be learning now. So let's start from the lever. What is a lever? A lever. Now, a lever, you can write it down. A lever is a simple machine that consists of a rigid rod or a stiff body. It consists of a rigid rod. A rigid rod means a strong rod. Are you getting it? A strong rod, like what I just draw. Pivoted about a stationary point. This rod will be pivoted around. This pivoted means fixed. There's a place that it is held, and that point is called what? The fulcrum. It's called the fulcrum. Now, an effort is applied at one point. It can be applied here to lift a load at this point, or this will be effort, or the effort will be applied here to lift a load around this point. Now, depending on the configuration of this fulcrum, this effort and this load gives the class of lever. For example, if this fulcrum, are we getting it, is at the center, then we have load here, we have effort here. It is called a class 1 lever. Or if this effort, are you getting it? If this effort is at the center E, and we have load here L, and we have fulcrum here, that kind of lever is called class 3 lever. Why class 2 lever? If the effort is at this side, we have E here, we have load here, then we have fulcrum here, it's called class 2 lever. But don't worry, that is what we are going to be explaining now. Now, type of levers, classes of levers. The classes of levers. So I would like to explain class 1 lever. Class 1 lever. What are class 1 levers? What are class 1 levers? Class 1 levers is a type of lever, are you getting it? Where the fulcrum, also known as the pivot point, lies between the effort and the load. Where the fulcrum, are you getting it? Lies between what? The effort and the load. Where the fulcrum lies between the effort and the load. This type of lever is called a class 1 lever. This kind of lever is called what? A class 1 lever. The fulcrum lies between the effort and the load. That's just all. Now, examples of class 1 lever are, let's look at some examples of class 1 lever. Examples are your pliers. Now this is how your plier look. It's your plier. Are you getting it? Your pliers. Now notice how your plier works. You have to apply effort at this handle, right? This handle, you will apply what? Effort, right? Then this point is called what? The pivot, or what? The fulcrum, or the fulcrum. Then this point is where you will put what? The load. So this point is called what? The load. So if you observe, we have the load here, L. We have what? The fulcrum at the center. Then we have what? The load, which is at the last point. So in this case now, this plier is what? An example of class 1 lever. Let's take your hammer for example. If I take a hammer, the hammer is like this, right? And that hammer, I apply it to remove a nail. This is a nail from the wall. And this is the wall. What will happen? Your effort will be here, right? Effort. Then your load will be at this place. This is the load, the nail, your load. Then this is what? The fulcrum. This is the fulcrum. So if you observe, if we start from this load point, you will see that we get to the load first, right? Before getting to the what? Effort. Before getting to the fulcrum, before getting to the what? Effort. So it therefore means that this configuration is like load before effort, before what? Load before fulcrum, before what? Effort. Or if we also start from the other way around, if we start from here, we start from effort to the fulcrum to the load. So it is a class 1 lever because the fulcrum is between the effort and the load. So another example we also have here, is your scissors. Your scissors, these are what? Class 1 levers. Your scissors, the class 1 lever. Alright, it's a class 1 lever. This is how your scissors look like, right? And this is the load you put, this L. This is the fulcrum, and this is your handle where you put your hand, right? So this become what? The effort point. So if we start the configuration, we discover that we start from load before what? The fulcrum, before what? The effort. L, F, E. So when you have L, F, E, or E, F, L, that is load before effort, before fulcrum. Load before fulcrum before effort, or effort before fulcrum before load, it is what? A class 1 configuration. Alright, Other examples of class 1 configuration are crowbars. Crowbar is an example of class 1 configuration. We have seesaw. Seesaw is also an example of class 1 configuration. Now note, class 1 configuration, are you getting it? Class 1 configuration, note this very importantly, are direction changer. Class 1 configuration are direction changers. For example, let's take the scissors for example. If I look these scissors now, are you getting it? Remember that when I apply my force, when I want to cut maybe a cloth, there's a cloth or there's a piece of cloth material attached here, so I want to cut it with my scissors. If I apply my force here, this one will go down, right? This one will go down, then this one will go up, right? The force here will go up. Now when this one is coming down, look, when this one is coming down, what will happen here? This side being traced, the same rod will what? Here will go up. So what happens is that the machine has successfully changed my direction, because the initial point was for here, for this point to go down, then the output went up. Now what are these plates? This plate went up. Now the output, the input was up while the output was down. So in this case we call them what? Direction changers. Direction changers. Also they are called force and speed multipliers. Force and speed multipliers. Alright, now let's talk about class 2 lever. Class 2 lever. Class 2 lever. Class 2 levers. Now, what are class 2 levers? Class 2 levers are done in a way that the load is now in between the effort, are you getting it, and the fulcrum. The load is in between the effort and the fulcrum. So when we have the load in between effort and fulcrum, then we know that it is a class 2 lever. Or we can have fulcrum first before the load, before what? The effort. Anyway, but in this case, what is at the middle is what? The load. In this type of configuration, it is what? A class 2 lever. It is what? A class 2 lever. Examples of this class 2 lever. Examples of this class 2 lever is your wheelbarrow. Your wheelbarrow. Your wheelbarrow is an example of class 2 levers. Now this is how your wheelbarrow looks like, right? This is the effort. Now this is the tire. And if you put a load here, right, this place will be the load. Then this is where you carry your wheelbarrow. That place is the effort, and this place is what? The fulcrum, because this is where the body is fixed, right? Now when I start my movement, I will start from E, right, before I reach L, before I reach what? F. It therefore means that L is at the middle, while we have E here, while we have what? F here. So it becomes E, L, F. Load is at the middle. In this kind of configuration, it is what? A class 2 lever. Another example of class 2 lever is nutcracker. A nutcracker. For example, this is how your nutcracker look like. Almost the same structure like a plier, but this one is a bit different because the load is in between. So your nut will be here. For example, you want to crack something like a cashew nut, your nut will be here, or a groundnut. This is your nut, right? Then this point here will be the fulcrum. This is where the nut will be, the fixed point will be. It's called the fulcrum, F. Then now note that this nut is also known as the what? The load. This is what you want to use the machine to do. Then this side is what? The effort. The effort. In this kind of configuration, what happens? We have what? F first, right? Before we have what? Load, that's the note. Before we have what? Effort. You will discover that in the FLE, the load is in between. The load is what? In between. And this kind of configuration where the load is in between the fulcrum and the effort, it is called what? A class 2 lever. A class 2 lever. Are you getting it? Other examples of class 2 lever are your bottle opener. You can research them on your own. If we want to do more examples, we won't have time here, but let me just sketch how your bottle opener look like. Okay, so this is the bottle. All right. Now this is the bottle. The bottle is the load. Right? Sorry, the bottle is not the bottle, the cover, sorry. The cover is the fulcrum. That's where the machine is fixed. The cover is the fulcrum. Why this point is the load, right? This point is the load. Why this side is the effort. So there's a point here that is fixed. That's the fulcrum. While in between is the load, while this side is the effort. I know this is a bit technical, but assuming there is more of a picture, like if there is a visual explanation, you can see it, but there's no problem about that. Alright, so other examples are bottle openers, nut crackers, and that's all. Now note that class 2 multiplier are force multipliers, but they are also called force multipliers. They are what? Force multipliers. They are force multipliers. Alright, so since we are done with this, the next type of machine we will now look into is called the class 3 lever. The class 3 lever. Class 3 lever. What is the class 3 lever? In this case now, the effort is between the load and the fulcrum. The effort is between the load and the fulcrum. The effort is between the load and what? The fulcrum. Examples of this class 3 lever is the human hand. Now this is your hand, right? The human arm. It's also called the forearm. This is your hand. For example, you took something. Maybe you took a ball. Now this side is where you will feel the effort, right? Is the effort applied. Then this is the fixed point, the joint. This is the joint, the effort. This joint is called the fulcrum because it's the fixed point. We are considering this part now. This part is what we are considering. We are considering from this part to this part. Are you getting it? Now this load here, what you took is what? The load. So if you observe this configuration, the effort is between the load and what? The fulcrum. This is a third class lever. Another examples of third class lever are your tongues. Are you getting it? Your tongue. Your forceps, and that's all. So thank you very much. Now let's talk about the velocity ratio of a first class lever. The velocity ratio of lever. Sorry, not first class. I don't know. There's a lot of I'm making a lot of vocal mistakes, but don't worry. Let's continue. velocity ratios of first class levers. The velocity ratios of first class levers, are you getting it? It's very simple. It's just, remember, for example, if this is a lever, the velocity ratio of lever, sorry, not first class lever, the velocity ratio of a lever. It is a lever and this is the fulcrum, right? This is the fulcrum. The distance from here to this point, if this is where you apply the force, this is called effort, right? While this place will be what? The load. Now, the distance from this point to this point is what we call distance of effort, right? The effort distance all over the load, and this point is called what? The load distance, the L. So velocity ratio here now will be this distance. Are you getting it? V arrow will be this distance, from here to this point, from here to this point. That is equal to dE all over this distance from here to this point. That will be what? dL. So just know the concept, not about dE or not about dL. Just know that it's from the fulcrum point to the effort point over the fulcrum point to the load point. Thank you very much for watching. In the next class, we'll talk about pulley, inclined plane, wheel, and axle. All will be in one video. So after that, we'll now talk about calculations involved in type of machines. Calculations involved in type of machine. Levers require much explanation. That was why the video was lengthy like this. Thank you very much. God bless you. Make sure you subscribe and share to your friends.